Hello everyone, my name is Kishan Agarwal. Today I'm going to present my AAT Tech Talk of Theory of Computation. And my topic is practices and tools required for software startups. So first of all, what is a startup? A company in the first stage of its operation is called as startup. Introduction to the topic. Software startups have become increasingly important to the economy and are a key to innovation. However, these companies face many challenges such as balancing short-term and future needs with respect to technology, processes, and tools. A typical startup follows 3 to 4 stages, namely initiation, stabilization, growth, and an optional initial public offering. This is the data of startups started between 2000 to 2017. Initiation is a time from the initial idea towards concept of the product and the first sale. Stabilization phase begins when a consumer receives the initial product and lasts until the moment the product is stable enough to be sold to a new consumer without causing overhead in the product development. The growth phase shapes the prerequisite for stabilization and ends with a decision point towards being acquired or getting new capital and thus evolving to a normal, small, or a medium-sized enterprise. Most startups terminate within first 2 years of various reasons, mostly because the market is not behaving as it was hoped. The product was immature or there will be simply not enough competency. One hidden obstacle is that within the development practices and tools which not only hinder product evaluation but might also create so much hassle that teams fight their software more than delivering the new product. Sometimes the growth is too fast and necessary software decisions are postponed to a point where the product exploits. Nets, Netscape was an example of an overly successful startup that eventually failed due to insufficient software practices and tools. Software Startup Survey. As to be expected, a clear majority of 86% of startups indicate that they have had to adopt agile methodology into software development process. Agile methodologies allows for delivering value to the customer in a shortened development cycle with constant consumer or customer feedback. These corroborated by a recent study that mentioned more than 70% of software startups adopt agile methodology. Startups like utilizing agile methodologies as it is the best method to survive in a volatile, uncertain, complex, and ambiguous environment or world. This is the data of startups in different phases: initial phase, stabilization phase, and growth phase, and using different software tools. Startups like utilizing agile methodology as it is the best method to survive in the volatile world. Test methodology is not so advanced, primarily looking to functional testing. These are some best free startup tools which a startup can use. So let us see the traditional testing method. Traditional testing methods have been in existence since the inspection of software development. They are primarily based on pre-organized stages of the software testing life cycle. In this case, the testing flows in unidirectional, that is from testing to maintenance. With the time, IT practices have evolved and so have testing approaches, as traditional testing usually fails to address the product's continuous testing needs. Performed. So, what are the features of traditional testing? Performed incrementally, the result is only released after all the effects or defects in the software are either solved or rectified. Entirely managed by the project manager, follows a top-down approach where the next phase of testing begins only after completion of the previous stage. Predefined steps to execute the process. Client's involvement is required only in the initial phase of testing. So what is modern or agile testing? With the rapid technology developments and increasing number of organizations entering into the software testing space, software testers are capable of different testing processes and optimizing these processes at multiple levels of testing by following modern ways of testing. These modern or agile software testing practices is an iterative and incremental approach. It typically covers all the layers and all types of testing. The entire testing team collaborates to find defect in the software while validating its quality, performance, and effectiveness. In agile testing methodology, both development and testing tasks are performed collaboratively while ensuring an exclusive tester for testing purpose. This is the key difference between traditional and modern testing principles. Traditional testing will find the bugs, whereas agile testing will prevent the bugs. Manual tests through UI, automation suits unit test, whereas your automated UI test, automated accepted test, and unit tests. So let us see why Agile preferred over traditional software testing approach. Transparency and continuous testing. Faster time to market and quick product release, scope of feedback, accountability and tighter alignment, better collaboration, high level of software quality. These all are given by agile testing, not by the traditional testing methodologies. Software startups relation with theory of computation. So software tools for startups can be directly related to the theory of computation in various ways. The theory of computation is a field of computer science that deals with the study of how problems can be solved using computational methodologies and algorithms. It encompasses concepts such as automata theory, formal languages, computability theory, and complexity theory. Here are a few ways in which software tools for startups connect to the theory of computation. Algorithm design, data structures. Let us see what is algorithm design. Theory of computation provides fundamental concepts and techniques for designing efficient algorithms. Startups often need to develop software tools that perform complex computations or solve specific problems. The theory of computation guides the selection and design of algorithms to achieve the optimal solutions. Data structures. Startups frequently work with large amounts of data, and the theory of computation helps in understanding and implementing the efficient data structure. It provides insights to data organization, access patterns, and algorithmic complexities, enabling startups to develop software tools that can handle data effectively. So we have seen different software tools which are used and testing methodologies. And here it deals with how our subject, that is theory of computation, relates to these software startup developing tools. First, we have seen algorithmic design and data structures. Some more are there, like programming languages. The theory of computation plays a significant role in the design and analysis of programming languages. Startups may choose or create programming languages based on formal language theory, automata theory, and parsing techniques. Understanding these theories helps in designing languages that are expressive, efficient, and capable of solving specific computational problems. Formal verification. Startups developing critical software tools such as security systems or safety critical applications often require formal verification techniques. The theory of computation provides foundations for formal methodologies, including model checking, theorem proving, and statistic analysis. These methods can help ensure the correctness and reliability of software tools. The next part is computational complexity. Startups often face scalability problems or challenges whenever their software tools need to handle larger data sets or increasing workloads. The theory of computation offers insight into computational complexities, which helps in analyzing the effectively or efficiency and scalability of algorithms. It aids in understanding the inherent limit of computation and can guide startups in optimizing their software tools. Machine learning and artificial intelligence. Many startups leverages machine learning and artificial intelligence techniques to develop intelligent software tools. Theory of computation underpins these areas, providing algorithms, models, and theoretical frameworks for learning, inference, optimization, and pattern recognition. Startups can draw upon these theory to develop and analyze their machine learning algorithms. So overall, we can say that theory of computation serves as a foundation and guide for startup developing software tools. It provides concepts, techniques, and theoretical frameworks that informs algorithm design, data structures, programming languages, formal verification, computational complexities, analysis, and machine learning. By applying all these theoretical foundation, startup can create robust or efficient software tools that addresses real world problems. So this way, the path where theory of computation comes into existence for better software startup tools. Thank you.